Yo, what's up, everybody? Welcome back. Today we are working on my map application. And today's topic is trying to optimize some of the bus transit planning. So, for context, the goal behind this is that I sometimes want to go from one place to another place, and I don't really like the way that Google Maps tells me to do it, right? Sometimes I'm like, I want to get on the bus and I want to go to the bar, and Google Maps goes, "Here, take these 3 buses and take these 2 transfers." And then you leave 5 minutes late. The bus doesn't come for another 30 minutes, and you've just wasted a bunch of time, right? So I have like things that I care about, right? I know that I can walk more than Google Maps seems to think. I know that I value like consistency of buses over maybe speed, right? I might want to walk a little farther to get a more consistent route. I probably value taking less transfers. And so like all of these things kind of point me to I can make some algorithm that's like pretty tunable and can give me all of the things that I want. And I also want to make it so that like if I feel like I want to make different trade-offs in different days, I can easily do that. So what we have right now is like this is like a map of Vancouver. I can like go over here and I can say like, hey, plan me a path from here to here, and it does just like a typical A star here. I can do things like I can say like I am a pedestrian, so if I take like I want to look at the sidewalks, right, and I want to take my sidewalk and I want to say like, hey, since I am a pedestrian, I'd prefer not to walk on the road. So if I do this now, if we like look at this path, should be taking mostly sidewalks. I think that maybe it didn't maybe do quite a good enough job there. So let's try to adjust this a little bit, but let's try this again. Set path end. Uh, wait, hold on. I'm not punching in the right thing. That's why. That's why. Much better. Much better. So now we can see that it is only taking sidewalks, no main streets. And I can go the other way. I can say, look, I'm a car, so don't fucking put me on the sidewalk ever, right? So I can say, like, we're going to have high cost for sidewalks. And then we look at this and we go, oh, he is going on the streets. Good job, Path Planner. Oh, we've been working on hooking up transit integration recently. So if I go towards some bus stops and I say, hey, set path start here, and we're going to turn on transit integration and debug mode because it's too slow otherwise. And I would say I want to go over here, and we go like this, and let's kind of like look at like the path planner, how it's kind of organizing itself, and you can see that he is trying to like walk along the bus routes and see how do we get to the place we want to go. And if we look at the route that it picked, it did say like, hey, go to this bus stop, take this bus over here, and get off the bus and walk. Great. Now, the A star algorithm requires that you have some sort of like heuristic to guide it, right? If we turn on this debug mode, we can see that we are inspecting a lot of nodes that sure, but they're not all the nodes, right? And so we're not just like kind of like dumbly walking about we're not dumbly saying just go to whatever's closest. We need to have some sort of like intelligent heuristic that will estimate what is the fastest way to get there, and it needs to underestimate that. It needs to make it so the heuristic that we pick never is more expensive than the cost, and that guarantees with A star that you'll get like the most effective route. And so what we do is we've kind of come up with this idea, however correct or incorrect it may be, that if blue is my bus routes, right? Maybe it's got something like this. Maybe we've got like a bus route that goes like something crazy like this, and I'm like here, right? And I'm trying to get over here, right? It looks like if you just went by distance that this is like the fastest way, but we know that if we walk towards this bus stop here, that we can kind of like take this bus around here, and it might be faster. And so what we do is we kind of just hook it at the closest bus route. Once we hit a bus route, we say, okay, we don't have to try that bus route anymore. We've already tried it. And we try to get like the next closest one. So if there's like another bus route over here that went like this, maybe, right? We will like first try walking over here. We'll be like, okay, this bus route has been like hit. We don't have to like try to navigate towards it anymore. However, we will still try to like consume those nodes, but we won't like try to like walk to this bus route anymore. Then we'll go over here. We'll be like, oh, well, let's try walking to this bus route then, because this is still closer than the final destination, and maybe this will take us over there. And the idea here is that as long as we always walk towards the closer of bus stop to final destination, we should always underestimate the amount of time that it'll take to get there, and we should find the most effective route. Now, what's really stupid here is the way that we are walking towards the closest bus stop is we look at for every step in our walk, so for every single node in our graph, everywhere we might go, we check every single bus stop and see how close it is. And that's fucking stupid. So fucking stupid. And so today's goal is to try to like minimize that cost in some way. And so my assumption here is that we can do something like try to pre-calculate at even intervals where the closest stop is. And not just where the closest stop is, but like where, like the vector of that closest stop, right? So we're gonna say here, we're gonna look here, and here, we're gonna look here. And what that should do is if we were to then try to sample here, we'd go, oh, we don't have a sample here, but we have this sample and we have this sample. What if we just interpolate these two vectors and we get like a new vector that points us approximately to the right spot? It doesn't have to be perfect, it just has to be good enough, right? And so the idea here is that we can then also do this vertically, right? So we'll sample here and here, and as we kind of walk in between these four nodes, we can kind of like bilinearly interpolate between them. And we should get like a reasonably accurate heat map of the correct direction to walk. And then from there, we can just run A star like normal. And I think that should be pretty effective. And I think that we can sparse out or sparsely space these points to the point where it should be pretty cheap to calculate. So I want to experiment with that, see how it works. And maybe it will reduce the cost a lot. Maybe it won't reduce it nearly as much as I think. Let's find out. So the plan is, I don't want to do that. I changed my mind. I was going to say we should show initially how slow it is. I don't really need to show an initial benchmark. It's really easy to prove that it's slow by just kind of like set path start, set path end, set path end. Oh, wait, debug path running off, set path end. You can see that took like 2 seconds, right? Like 1 Mississippi, 2 Mississippi. That's like slow as shit. So we don't really have to show like a proper benchmark here. We know it's slow. And we do know that this is a likely cause. And so the plan of action instead is to let's do the calculations. I want to render the grid on the map somehow. So I think that would be nice to see as we step the algorithm. We can kind of see like a heat map of like which bus routes it's trying to get to. Then we can kind of look at linearly and like bilinearly interpolating on the CPU so that we can actually like use that map in some way. And then I think that likely we don't have to compute the whole map up front. We can probably like lazily pre-compute each of these sample points as we need them. And then we'll see how much faster we got. That's the plan. That's the plan. Let's jump in. Okay. So where are we going to do this calculation? Probably it's going to be part of the path planner. That's where it makes most sense. And I haven't really thought about this very much at all. I guess we're gonna have like some sort of like bus stop heat map or something. Closest stop lookup. That seems right. And he's going to have some sort of grid, right? So we're gonna have like width. Const width is going to be what is this width? In like number of buckets, I guess? Actually, we already have a type that kind of does this for us. We have this map buckets type. Const. So I think, let's see if this type fits us. So we have this map buckets type that lets us kind of store things this is close, but not quite the same. So this map buckets type allows us to kind of say like, if we were to split up our map into like chunks, like you might have like 10 samples in here and 10 samples in here and like 3 samples here. The map buckets is to like let us basically get these collections of points, which is close to what we want, but not quite the same. So it's not worth reusing. So we'll make our new type, and why is the highlighting fucked up? It's fine. So the question, I'm trying to figure out if I want my width to be in the units of like the space, like XY float, or if I want it to be in number of samples. And I think I do want it to be number of samples. So let's start with what we did, like, maybe we do 50 by 50, right? So that we have 250 samples. Is that right? 25, that's 50 times 50 is maybe 2,500. That sounds right. 2,500. And so maybe that's too many. We could maybe start with maybe even less. Let's kind of start low, and when we visualize, that way we'll be able to visualize how shit it is, and then we can increment and see if that improves it. Okay, which means that we're gonna have some sort of storage, right? which is going to be like width times height number of elements times the element that we want. So what is the element? Well, I guess it's going to be a vector, right? We said that we want to store not just how far we are from the closest bus stop, but also like the direction of the closest bus stop, which will help us with interpolating in cases where we go over the bus stop, right? If we are like above it and below it, we need to make sure that the average of those two things evens out to 0. Okay. And I guess we are going to initialize this thing sometimes. Closest stop lookup. And he's going to be initialized, I guess, with the stop list. Which bus stops we want to look at, right? Because as we approach different, like as we hit different bus routes, we no longer are trying to get to the bus stops of bus routes that we've already hit. So we need to make sure that like when we initialize this thing, we initialize it with some sort of like list of nodes that we care about. And we probably want their positions as well, huh? So we're going to want like, I'm thinking. We're going to want the point lookup. Okay. I guess this could probably be taken in by value since we're probably not going to store it. Probably. I'm looking at this and I'm thinking it's actually probably kind of sketchy to store these in line like this because there's a good chance of Stack Overflow. But if we just make sure that we're careful that this only ever returns a heap allocated version of this thing, then it's probably fine. But if we're always going to heap allocate, we might as well just heap allocate the array anyways. That's fine. So which means this needs like an allocator. So we're going to do like alloc. Why is this not auto-completing? Alloc init, or what am I trying to say? Alloc width times height vectors. And this is maybe he's failable. And we're going to have like storage as you will try this. Yep. Then we are going to return the storage. And we actually have to do something. We have to initialize the storage. So we're going to go like, something that we're missing here probably is we also need to know the kind of bounds of this thing, right? So we're going to have to go, we need to convert from like lat, lon, or I guess from like meter position. I think that we unwrap the map and we store things as like offsets from some arbitrary location in the map. So we need to go from like offset to closest 4 points, right? That's what we're going to have to do. So I guess we probably want to sample if like this is our kind of space that we're working in. I guess we probably want to sample directly on the corners. Maybe? It's like there's kind of two options here. One is that you sample like kind of offset from the corners. One is that you sample on the corners themselves. I guess if you sample on the corners, then you will always be between 4 points, which makes the rest of the math easier, I think. That's kind of like less special cases, right? If you sample here, here, and here, now all of a sudden what, like you get this point, this is really easy to think about. You kind of like just sample, you interpolate these 4, right? But if you end up over here, you kind of have to like what would you just take this value in the corner? I guess so. So you have to like special case that. Fuck that noise. Okay. So this means that we are going to include the corners. So if our width of this thing is like 100, let's say that our width of this thing is 25, and we have 25 points that we want to sample. I always struggle with this like off by 1 thing. So let's kind of start in the simple case. 2 width, 2 points. Okay, sure. So that means that the spacing between these is 1. Wow. Okay, that kind of solves my problem. So here, I guess we're gonna start like let's call this like X buckets instead of width and Y buckets, or X samples. These aren't buckets, these are samples. Okay. And so now this is X samples times Y samples. And here we're gonna have to take in the like bounds. So where does, I guess we'll just take in like width as an F32 and height as an F32. Use tessellation shaders to dynamically tessellate the grid. I don't know what any of that means. And I won't know. So we will just keep going like dumbasses. Doing whatever the fuck I was already gonna do. Okay, so we probably want to store these things, probably. In order to do like lookups, probably. And so we're gonna have to store width is equal to width. And height is equal to height. Simple. And now we're gonna have to do some sort of like, we're gonna iterate our points, I guess. So we're gonna say like for 0 to X samples, we're gonna do something. Who knows what yet? Probably want to iterate Y first. And then we're gonna do for 0 to X samples. Here we're gonna have to like convert these into a coordinate somewhere. So these are gonna be like, what did we say? We said if width is 2 and num samples is 2, spacing equals 2. Right, so we want it to be like X samples over width is X over width? Yes. Yes. X over width. This is the X float value. I guess we're going to say like float from int X. Y is the Y, and then we'll say that the X meters is going to be the X floating point value over the width, and the Y is the Y over the height. All right. And then we just kind of do whatever calculation we were doing before to like kind of figure out which is closest. So we go like for stop list stop. We get its position. Stop pause is this. And then we compute the distance. So what does this give us? Point lookup get gives us a map pause. And we have our position. So we can do like stop pause minus our pause. So I guess we'll do like const sample pause is a position with x equal to xm and y is equal to ym, and then we can get the stop pause. We can subtract the sample pause, and we find the closest one. So this is going to be like closest dist is going to be stood math inf of float clear 2s, and the closest stop ID is, I guess, undefined. And then what? We say this is we don't actually want closest stop. We want closest vec. Right. And then here we can go what? What? We must have this code somewhere already, by the way. When we call heuristic distance, we call path planner distance, which is just a b length. Okay, yeah, fine. So there's nothing crazy to do here. That's fine. And we do just say min dist is the distance, and we do the minimum of these two. Yep, okay. Okay, so here we say v is equal to this, and the distance is the v length. We actually don't need the full, we don't need the length directly, we can use length squared, which is cheaper to calculate. And then we say if closest dist is greater than dist, we set closest dist to dist and closest vec to v. Then we should be able to say, I guess here we need to assert that the stop list has at least one element in it. But I don't like that. I don't like that. So what can we do instead? I guess we will do that because I don't know what I want to do here yet. But surely we need to handle zero length in some way, shape, or form. We have to handle that somehow, but I just don't know how yet. Okay, so then at the end of this, we say storage at y times x samples plus x is equal to closest vec. All right. Seems reasonable. Seems reasonable. Then we are going to have to do some sort of lookup of these. But for now, maybe we start by just doing this initialization, and then we can try to render the stuff first. I think like the earlier we start doing some rendering, the easier it will be to understand what the fuck is going on. Tessellation uses many LOD systems to dynamically give more detail to models close to the camera. Sure. I don't really understand. I understand LODs. I don't really know what tessellation means. Is it just like you take triangle and turn it into two smaller triangles? Maybe. Other use cases use procedural Turing generation in the sense you generate fine-grained grids starting from a coarse grid of fly built into hardware and GPUs instead of using massive grids on CPU side. Pretty much, yeah. So is it that you upload the high-res version from the CPU to the GPU, and then the GPU can automatically downscale it to different LODs? I guess. Which I think isn't. I don't think it fits here. That's one way to do it. Gotcha. Okay. So we have a closest stop lookup should be initialized here, and so I guess we just kind of shove this in here. It kind of does apply here. Maybe I don't understand why. Because you can redo the group with the higher resolution. I guess, yeah, because on the GPU we could compute if you could just like pre-process this whole thing on GPU if you had an upper bound of how many stops you might have to look at. I think you could definitely do like give me the point distance to one stop on the GPU easily. I don't know if you could do the closest point to any of these stops easily, because if there's like 5,000 stops, I think that might be out of the range. Like I don't think you can loop to 5,000 in shader. I could be wrong there, but like I guess you could pass into texture and then loop pixel by pixel for all of the stop locations, but not sure if like I'm under the impression that doing like hard loops like that on GPU isn't very good, but I don't know. Anyways, doesn't matter. I'm gonna do this for now. We can always GPU optimize later. That would be a fun little side quest. I would do a really low res grid. Yeah, I figure I'm doing a low res grid anyway. Like 25 by 25 is probably fine. We might even be able to go lower. We'll see. Okay, so we have this like closest stop lookup. I guess that this is only going to be done in the case where we have transit data. So it's going to go here. And then on initialization, here we have to construct this thing. So we'll say closest stop lookup is equal to try closest stop lookup in it. And we have to pass in the allocator, the node IDs. So it was like, I think we want to do like const trip list equal to this. Boom. Right. Then this we say we have the trip list of the trip list. And then we can say trip list get trip stops. And then here we can say closest stop lookup in it with the allocator, the stops, and something else. What's the other thing? Point lookup. Points? What do we call here? Point lookup is points. Yep. And this is already a pointer. And then we need the width and the height, which I don't think that we pass in right now. So we're gonna say like meter. Do we have like metadata pass in here? No. This is fine. We'll kind of do this. And then here we get like meter metadata width and meter metadata height. All right. Closest stop lookup. And this has to be tried, and then when this becomes like closest stop lookup, and then this needs like error defer, trip list, deinit. We might as well throw this one in here as well. Except closest stop lookup doesn't have a deinit, but he should definitely have one. And this is like alloc free self-storage. So this takes an allocator, I guess. I swear that sometimes I press a button, I think when I accidentally reset font size, it feels like that fucking changes the font. I don't know if I'm fucking high for thinking that, but it really does just not look right after. Okay. So transit state also needs to deinit this thing correctly. So here we have some closest stop lookup deinit, and I guess we'll store the allocator inside it. That's fine. All right, which means that we have like alloc is X allocator. And then self.allocator. Here. I don't know. Random question. Could you turn my equation into code for more endings than grains? I don't know what the fuck you're talking about. Okay. So we have this thing now that we should be able to interact with. He's not ChatGPT, bro. Yeah, it does feel like you're treating me like ChatGPT a little bit. Okay. So this probably doesn't compile in some cases because app.zig needs to construct the path planner. And he needs to pass in the meter metadata after node costs. Oh, which we actually don't keep track of, which is kind of interesting. But we should. So we actually need to here store the like metadata. We need like meter metadata. Because what happens is we take in like a map as a bunch of latitudes and longitudes, and then we like unwrap that thing into like more square space. And then we get like a width and height in meters. And we need to store that. So that we can use it here. Makes sense. Okay. Sorry, I don't know what the fuck you're talking about, but you also seem to be derailing and not talking about anything of value. So I apologize. I'm going to time you out because I don't want to deal with this. It's my chat and I can do what I want. Okay, so this expects of type trip list, and you found const. Whoa, what is he complaining about? He's actually fine. Okay. Okay, Pathfinder trip list. Oh, I see, because trip list is const here, and we can't call get stops if it's not. Got it. And then he's looking for map data point lookup. So dereference, I guess. Map data has nothing, no pause. Oh, this is a lin, I think. Lin pause, not. Where does this come from? Maybe it's map data map pause? Point. It's lin point. That's where I was lost. No field length 2? Really? I thought we definitely had a vector length 2. I guess we don't. But we can make one. Simple enough. we return the square distance, and then here we return the square root of self length 2. Boom. Simple. Expected allocator found type. That's true. He's mad. And then in path pointer benchmark, we have to pass in where the fuck that we said we pass in. It's the meter metadata. So this is meter metadata. Are you using GLM or your own vector library? It's like the most rudimentary vector library of all time. Calling it a vector library is very generous. It's just an X and a Y. Like, okay. So it looks like it builds. And so now we can start looking at like, can we render these things? So I think what I want to do is, I guess this probably needs a new program that's going to run on the GPU. And we are going to upload to the GPU all of these points. Simple. But we have to upload their locations as well in meter space. So we're going to say like, yeah, that makes sense, because all of the current rendering all works in meter space. But the difference between like our existing shaders and this shader is that it's going to have to keep track of the vertex like shade, like the value of this thing as well. I'm trying to decide if I can get away without some like without duplicating work here. I don't really know how to manage like multiple shaders reusing the same code. Right, because like kind of like all of this stuff is going to be like almost the same in our new shader. Our new shader is going to like position the camera according to the latitude center, the longitude center, the zoom, and the aspect ratio. All of that has to still happen. It's just that he has like another input here. Right? And it's going to be like offset, right? You can use a UBO if you want to share uniforms between shaders, but I guess I still need like the same, like it means that my shaders still need the same like sets of uniforms, right? And then here we would need to do the same math. So I guess like I don't know if you can like include a like helper function in shaders. It also doesn't really matter. Fuck it, I don't really care. So we're just gonna do like source, and we'll call this like vertex shader for whatever the fuck we're doing now. We'll call this like closest stop. I don't really want to think too hard about this, so we'll just copy paste this right now, and we'll say that we have like we'll call this like offset, or like closest stop. Here, this should be a vec2, and we'll call this vertex pause. You'd use the UBO on the shaders that it's needed, not every shader. No, but I just mean like these two shaders, like we would still, I assume that the UBO, you say like bind this set of parameters, but I assume that the shader would still need to have those parameters as inputs, if I understand correctly. If it behaves like the other buffer objects. In which case, like I'm more worried about like this duplication than anything else, but it's fine. It doesn't really matter. Doesn't really matter. So we're gonna here take in like the position is gonna come from vertex pause 0, 1. We'll put fix me on here and like dedupe with other shader, and then we'll have like fragment closest stop, and this is gonna like, I guess he is going to take in, he's not going to take in RGB anymore. He's going to do like, he's going to take like an input of the closest stop, and I assume this gets interpolated on the GPU, so I assume I don't really have to worry too much about this. And we're just going to basically do some sort of like closest stop. Is there like a, do I have access to functions that will give me what I want in GLSL? GLSL vec2 length. Like, do I have to do this math myself? Not that it really matters. But we do have length. So we will kind of say that this is the length of closest stop. In which case, I think that this is how we want to do it, because it means that the vector will get interpolated between coordinates not the length. And that's what we want. That's what we want. So then I think I want to go from like red to blue. So the closest things are red and the farthest things are blue to indicate hot and cold. And we're going to want things that are like super, super fucking close to have really like be like 1.0, and things that are very, very far to be like 0.0. And then we'll just subtract that for blue. Which I think that we did last time with like an exponential function. Where did we do this before? We did this in like the closest wave visualizer. So it's like I think we have like a find closest way find debug wayfinding. That sounds right. Set debug wayfinding. So this sets debug wayfinding. This must be used somewhere where he sets the point size to like this. Oh, this goes from like infinity. Okay, so I want some function that's like 0.0 goes to 1.0 and infinity goes to 0. So we want like 1 over x, and we just need to make sure that x is like at least 1. That sounds right. So float r, we'll call this like dist is this. Then we get like r is 1 over x plus 1, I guess. And b is 1.0 minus r. And then we have r0, b1, I guess. I guess. That seems reasonable to me. That seems reasonable to me. Okay, sure. So then we just need to make it that our vertex closest stop, he must have like an output. And these probably can't have the same name, so we'll call this frag, I guess. Or maybe we call this in closest stop, and then we have closest stop out, and we just say closest stop is equal to in closest stop. That sounds kind of right to me. All right. So now we need to like do something with these. So I guess we're gonna copy our renderer and we're gonna edit like source, and we'll call this let me think. We're gonna call this the closest stop. I guess we'll call this like heuristic renderer. That feels more correct. And I'm just gonna start by copy pasting this whole file like a fucking dumbass, right? And let's see, we're gonna have a vertex array. I don't think we're gonna have an element array. We are gonna have all of these uniforms for the latitude center, the longitude center, the aspect, the zoom. All of that needs to come in, but RGB does not have to come in anymore. Point size is no longer a thing to worry about. Maybe it is. I guess maybe we'll want to render like the individual points, and maybe we'll want to draw them. Fuck it. Maybe not. I don't know. We'll see. And now what? The number of street segments, we don't need any of this either. Index buffer doesn't exist. I don't really know if that needs to exist in this one either, to be honest. That feels like... I don't really know why this exists. Oh, I see. Never mind. I get it. That's kind of the... Given point IDs, he renders them with this index, which is not what we're doing. We're creating a new buffer with new indices that aren't necessarily attached to the grid. Or yeah, they're not attached to the node graph from OpenStreetMaps. So here we don't have like point data, we don't have index data, none of this stuff matters. What we do have is, I guess, the let's see, what do we have? Path planner. What do we construct here? we constructed this like closest stop lookup who's going to have a bunch of, he's going to storage of points. Floating point points. Okay. So this is going to take in the values as well as the positions. I guess he doesn't need to take in the positions as a vector or as like an array of points. He's going to take in like the values vectors. He's going to take in like the width and the height. Does this make any more sense than just taking in this lookup class? Maybe we just take in the fucking class. That doesn't seem crazy to me right now. So maybe this stuff goes into like source, closest, stop, lookup. Right? Maybe we kind of just tuck this whole thing over here. So this is going to be, we need to import a few things. Path planner, we take in probably like this stuff and like this stuff. Anything else we need? We need like node ID. And we need like the point lookup. And the closest stop, so we know we just say like const closest stop lookup is equal to this. Boom, boom. All right. So he's pretty happy. And that means that in our like renderer now, we can just take in the closest stop lookup. Lookup is a closest stop lookup. And then this is like const closest stop lookup is equal to import closest stop lookup dot zig. Okay. Fix me prune imports. All right. VS source, this is vertex closest stop now. And fragment closest stop. And then what? What happens here? So we're going to create a vertex array. We're going to bind the buffer. And we're going to set the buffer data to something. I don't know what yet. This probably needs an allocator. Probably. I don't really know yet. But I think we're going to like allocate a buffer of all of the points. And put the vectors next to them. That is what we have to do. So here we're gonna need like some sort of like sample iter. And yeah, that seems right. And we can do like next is going to give us some form of output. Right? And it's going to be like, the output is going to be his like X position, his Y position, and his offs, or his closest point. Closest point, yeah. And here that means he's going to need like, basically a reference to the parent. So he's going to say like, inner is closest stop lookup, probably constant, probably. And I guess he's going to have like his index. Like this, right? And then for each one, he's going to say like, if IDX is greater than or equal to inner storage len, he's going to return null. Otherwise, though, he is going to return the thing. So his X and Y are just going to be calculated by index over like this. So maybe we have a function like index X index to pause, takes in the index as a usize and the width as an F32. and returns a position. Maybe yeah, it's fine, it's fine. And that's just this. So this is IDX is a float, is from IDX, and then we return this thing. And I guess we can call this isn't even the x IDX pause, this is just IDX to pause, and we'll call this the len. And then this is a kind of abstract for both x and y. So now this gets like IDX to pause of x and width. And this is the same for y and height. This kind of goes away, right? Then we can call this down here, right? So this is the x, y is self inner. I guess our x IDX is our self IDX modulo self inner. It's like x samples, yeah, like this. And then y is divided by x samples like this. We have x IDX and y index from self inner width and self inner height. Right, now we can like return this thing as x is equal to x, y is equal to y, and the closest point is equal to self inner storage at self IDX. Yep. And then all we have to do here is defer self IDX plus equals 1. And there we go. Simple. God, I'm so into iterators recently. This is just like, it just feels so nice to do it this way. Just feels so nice. Probably helper functions go kind of down here somewhere. I was waiting for that snarky comment. That defer works. It should. I don't see why it wouldn't. Then we're going to pub function sample iterator. He's going to take in self, closest stop lookup. He's going to return a sample iterator. He returns something where it's just like dot inner is equal to self. There we go. So now we should be able to go back into like our heuristic renderer. Was it heuristic renderer like this? And now I can do like closest stop lookup sample iterator. And we can say, while sample iterator next item, we kind of like push this into some vector. So our like we're gonna have like const vertex buffer is going to be a new vector that's like the closest stop lookup storage len times 4, right? So we're going to have the x position, the y position, the x offset, and the y offset. So for each element. Then here, for each of these things, we kind of just say like var I equals 0, and here we must have like a defer vertex buff free. And this is a usize, and defer I plus equals 1. Maybe we just do I plus equals 1 at the end. That's probably fine. And then here we do like vertex buff at I. This is plus equals 4, I guess. Yes. Yes. So I is going to equal item.x. I plus 1 is item y, and then this is, I guess I don't know why I copy pasted that. Like I thought it would help me at all, but maybe it does. Closest point dot x and y. There you go. So now we have our buffer is full of x's and y's and their offsets, and we should be able to create a vertex array, bind the buffer, upload the buffer data. So it's like a GUI GL buffer data from this GL array buffer. And we set the pointer to vertex buff.pointer. And I don't know if the length is supposed to be in bytes. It must be. So this is a pointer cast. Looking at the API, it's like pointer cast this, vertex buff.len times 4, because it's 4 bytes per float. This alloc needs to say that we're fucking allocating floats like this. And this is GL static draw. This shit will not change. It will not change. Maybe it will, but maybe it won't. Now we need to like set the vertex array data. So we have to say like, given this buffer, how is the data laid out? So we'll just kind of yoinkies this shit. And what are the parameters here? This is the index, size, type. So surely this is 4 now. No. So for the first thing, for our first trick, we have 2 elements. Index, size, yeah, so 2 elements. Type float, normalized false, stride and offset 0, I guess, because they can figure it out automatically. I kind of want to say that stride here is probably 4. And then here we probably want to do like 2, 4 like this. So we want to say like the first element is another vec2 of floats, not normalized, but he starts at position 2, and again, we kind of jump these by 4. I'm pretty sure is what this is supposed to do. Oh, stride is the other one. So that's 4, 4, 0, 2. And then we enable 0 and 1. I think that's how this works, but I don't actually fucking know. I'm just kind of guessing. We'll try this, and when it doesn't work, we'll come back to these as a very potential problematic section. Lat center, long center, zoom, aspect, all of those are still available to us. RGB are not, point size still maybe is, I can't remember. We did leave point size in, so we'll leave it in here as well. We don't have an element buffer anymore. This goes away. This goes away. This goes away. These all stay. These go away. These go away. All right. When we bind this, we want to bind the array object and use the program. Okay. We probably don't need to take in this view state anymore. This is defined somewhere else. Upload map points doesn't need to be used anymore. Set up map doesn't need to be used anymore. And now we have the interesting part. We render this data using, I guess we'll import. I think view state goes from renderer into our like, this will go into like our utils. So GL utils now gets this view state, which means that this map pause comes from here. I can't comprehend what replacing Google Maps means. We're trying to make a path planner. We're trying to make a path planner, and it kind of works, but we have a lot more work to do to get it to hook up to buses. So right now we're working on working with bus data. So we have like a path planner that like we think might work for riding the bus, except it's slow as shit, so it's kind of hard to tell how well it actually works. And so we're working on speeding it up with doing some sort of like spatial lookup of where the closest stop is to each node on the graph. Okay, so here now we were in our heuristic renderer. These are all the pieces. We bind this thing, and on render, what are we going to do? We are going to set these parameters. That still has to be done. That makes sense. And I guess we're going to GL draw arrays in some way. I just don't know what that means yet. I'm just going to delete most of this shit because most of this doesn't matter. And let's just say like GL draw arrays. And I guess like, we kind of want to draw row by row, huh? Like, if our stuff is kind of like we're kind of pushing it in X, Y order. Maybe I'll draw less points, so I don't have to draw as much. So if we're trying to draw this stuff as like a bunch of quads, I guess we probably do need an element buffer, right? So if we have like 0, 1, 2, 3, 4, 5, 6, 7, we kind of want to draw like this triangle strip, right? So we want to draw like how does this work again? You do like 0, 4, 1, 5. And then 0 gets kicked out. 0 get kicked out by the 5, so then we're drawing 1, 4, 5. Then we want to kick out 4 and replace it with 2, which makes sense because then the latest 3 is 1, 5, 2. And then we kick out 1 and replace it with 6. So there's some sort of like, I guess it's just vertical first, then horizontal after is the index order. So we do need an element buffer. I guess before we do this, let's try to make some incremental progress. So before they do this, let's just render the points themselves. And so we can render these, and how many of them do we need? We need to know how many of these things we rendered. So we'll say num points. And then we have here num points is essentially just closest stop lookup storage len. These are the number of points that we are rendering. All right. Because I think that if we try to get too fancy here, we're definitely gonna like fuck shit up. So this is just gonna be self not what was it? Inner num points. There we go. So what we should see here is that we should see each point rendered. I guess we should set the point size. So we should see each sample rendered on the graph with a color that represents how close it is to any bus stop. That's what we should see if this works. Now, I don't think we even compile right now. So we have to, there's a few things to clean up here. Closest stop lookup now gets imported. So closest stop lookup is equal to import closest stop lookup zig. View state is no longer defined in renderer. Did I not import const view state is equal to gl utils view state? I thought we did that. View state is not marked pub. So in app zig, we are using renderer view state. We should just switch this to gl utils view state, which I think is defined. It is, great. Now everything compiles. We need to construct this heuristic renderer. And I think we do this once. Ooh. I guess we'll construct this on each render for now. Which means that we need like a dinit function here. Which is going to basically free our element buffer and vertex buffer. I guess we need to write down the VBO so we can free it. So VBO is equal to VBO. And then it's like GUI GL delete buffer. And GL delete vertex array, which doesn't exist yet. GL delete vertex array given this ID returns nothing. And then we need to implement this in native Glyphwa. We need to create the binding here. So it should be pretty straightforward. It should just be GL delete vertex array, takes in the ID, he bitcasts it, and then says GL delete vertex arrays. Boom. Chillin'. Never been exposed to coding in Zig before. Very interesting workflow. Love the stream, brother. Hey, thanks, man. Appreciate it. Hopefully the workflow doesn't feel stuck to Zig in any way. It should be generic, but I guess maybe it's biased towards low-level languages in general. I suspect that this build, I don't know why Zig build check is passing, because I feel like the functions that we just implemented were not implemented for every, oh, we never called the init, so the linker doesn't realize that it's a fucking problem. That's why it gets optimized out. So we actually have to we have to use this thing. That's probably why these things passed. So heuristic renderer is an import of heuristic renderer Zig. Okay. I hope we spelled that right. No. What do we call it? Oh, I spelled it UE, which I feel like is wrong. I think it's EU. It is EU. That's annoying. Fix me. Hue to hue. If it's hue, it's hue. And then in render now, I'm just going to like blindly construct this thing. If self path planner, we can construct a new heuristic renderer. Given our allocator, this probably will end up being like a long-lived thing later, but I just don't want to deal with it right now. So we're gonna have like pp dot transit state dot sum dot closest stop lookup, which means we have to say if pp transit state is equal to sum. We do this. Okay. Okay. Yes. Okay. And then we do like renderer bind. And then bound dot render with self view state, I guess. Sure. And then defer renderer dinit. Okay. Who knows? Let's just see where this gets us. Because I think we've done enough without seeing any progress to the point where there's a good chance that everything's broken. By the way, an efficient way is to create a triangle strip per row. Order the vertices by going up, down, diagonally, right, up. Repeat. So 0, 1, 1, 0. That's kind of what I decided. Yeah, when I drew this out, that's kind of the conclusion I came to. Here. Just haven't quite got there yet. I want to start with points, then get to that. Because I want to see that, like, there's a lot of things that we could have got wrong in, like, the point data management. So I want to see that first, then move on to triangle strips. All right. So what's broken? I knew you were trouble. So this needs a pointer to this thing so that we can run this. I guess really sample iterator could just take it by const and then it'll be fine. This expects a pointer now, but I've changed my mind. So can we go back here and I don't think these are true. Next is not marked pub. That does feel true. So this is pub. Out of memory does not support indexing. That's true. So this needs to be tried, which means this needs to return an error, which means that whoever calls this thing needs to write try. Expected void. Oh, so catch panic. Uh-oh, because I don't want to deal with this. Fix me bad panic. All right. Does that do it? That does do it. Okay, so it might work. It might work. And so if everything works as expected, we should see a grid of points. Fuck. No GL delete pointer. Right, because that's what I was saying, is that that's not implemented. So we'll just implement it in SFMAP. What is it called? It's called like native no GUI. And we will just kind of, oh fuck. Native no GUI. Since we don't do anything, we can just do GL delete vertex array ID. I guess we take it in as an i32 void and kill it. Much better. Fuck. Just kidding. Not much better, because we need to export function GL delete. Oh, capital A. Capital A as in ass. This fucking sucks. such a fucking stupid thing to say. I take it back. A as in I'm so angry. That one feels less stupid. Still stupid, but maybe a little less stupid. Okay, so we're hoping that we can initialize a path planner in transit mode, and we'll see a bunch of dots on the screen. More likely, we'll segfault. That seems much more likely to me at this point. But let's try it. Start, end. Enable transit integration, end. So there's something wrong here where this, debug path planning probably is what we want here. Now I press end. So I see no dots. Oh, I see. What's this? I see a dot here. Maybe the dots just shouldn't be white. Why are the dots white? Okay, let's look a little closer. Heuristic renderer. We are using fragment closest stop GLSL. And are we compiling these things? We are compiling this. We are compiling this. Okay. Okay. Fragments closest stop. So can we, I guess here, if we fucked this math up, then R and B could both be high, but then this should not be. Can we just draw them as in black for now and just kind of figure that out first? And I'm late for the bus. This is the problem. This is the problem. I wish maybe I should like turn off the satellite stuff to kind of speed up initialization, but it's fine. Start, end. Okay, do I see anything? What if we step path planning a few times? Okay. Oh, okay, wait. There are some points drawn here. They're just kind of... What the fuck am I looking at? Set path end? So these are not in a grid. Also, they're just red, and I don't really think they should be red anymore because I changed this to just hardcode black. Can we make them green for now, just to see? Like, I feel like I should be seeing, like, errors or, like... I just feel like I should be seeing something that's not what I'm seeing. We might want to try the WASM version 2 to see if, like, WebGL yells at us in some way that, like, OpenGL is not yelling at us. Set path start, set path end. So, yeah, I don't understand why I'm seeing red dots in the corner there. Okay, let's also set the vertex... Can we set the point size to be, like, fucking, like, mega big? Maybe, like, 50? Just to see if those red dots that we're seeing in the corner are related to our new renderer. Because if they are, then we should start seeing those mega dots being, like, those dots in the corner being, like, you know, just blown the fuck up. Because they're definitely not there right now. They're not here now either. They're not really any bigger. And they're drawn, like... I don't really understand what I'm seeing here, to be honest. I guess if we didn't bind the right program. Okay, let's get in the weeds a little bit. So compile link program returns an I32. So let's okay, before we do this, let's run the WASM version to see if it yells at us in any way, shape, or form. Oh, are we not getting debug logs? Oh, I can't. I have to run in release mode though. Fuck. Okay, we'll try. We'll just try this. Refresh. GL delete vertex array is not a function. That's a really good point. So we have to implement that on the WebGL side as well. So we'll call GL delete vertex array. Calls GL delete vertex array. And then we need to bind this. Here. Delete vertex array. All right. Refresh. Okay. So he's doing something. And if we go start, end, an error occurred. Version directive must occur in the first line of the shader. In only support. Okay. Thank God. Okay. Errors are great. I love errors. Vertex. So there's a new line here that there shouldn't be. Fragment, close to stop. That one looks fine. All right, let's try again. There we go, dude. I'll take some errors over just silently failing any day of the fucking week. Start. End. Error occurred. X, undefined identifier, at 9. So this must be in the vertex shader? Or the fragment shader, I mean? Fragment, close to stop. Yeah, that's a really good point. That does look like it's not a variable that's defined. All right. Start. End. Wrong operand type. No takes a high float and right int. Really? What line was that at? 9? I guess. Fine. If you want to be like that. If you want to be like that, you're going to be like that. What a whiner, this guy. Start. End. Okay, so now the shader compiled, but I don't see... Oh, here we go. Oh, yeah. Stride and byte offset must satisfy the alignment requirement of type. Okay, so let's... Vertex attribute pointer. He's bitching. He's whining. He's a little whiner, this guy. So heuristic renderer. He has vertex attribute pointer. Oh, so these need to be in bytes, I guess. Not in elements. We can try again. Start. End. Error spam? Buffer for target is null. Okay, wait. Okay, so this is... We at least got a green dot. One big-ass green dot. That's good. He is complaining about the buffer. Buffer for target is null. So we create a buffer. We bind the buffer. Do I have to create the buffer before binding the vertex attribute array? I don't think so. I guess maybe we have to bind the buffer again down here. I thought that it auto binds with when you rebind the vertex attribute array. That was my understanding. But maybe not. We're kind of doing it like here, I guess. This is not my understanding of how it works, but we'll try it and see what happens. And if this doesn't work, we'll have to think with with our brains. Yeah, buffer data, buffer for target is null. Oh, that does kind of sound like it's in the buffer data. Buffer for target is null. Buffer for target is null. What does that mean? The array buffer is global state. However, the element array buffer binding is blah, 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 blah. Each attribute which is stated in the vows. You do not need to rebound the VBO, only VL. That's what I thought. So it could be if like VBO is coming back as something unexpected. Buffer data buffer for target. Buffer data. Buffer for target is null. Buffer for target is null. Buffer for target is null. What does it mean? Am I just using GL buffer data with the wrong stuff? I say, this is what I did before. This is what I did here, which is very similar. Very similar. Is it possible that like GL create buffer is giving me some bullshit? Can we look at index.js? When we create a buffer, what does it do? Can we just like console log red? Like, what does this do? And I guess it should be also this GL objects at red. I guess how do we, it's .get. .get. What the fuck is going on? What the fuck is going on, man? You know? Okay, so we get some WebGL buffers. Great. Start. End. And so here we're getting a lot more WebGL buffers. And these numbers are increasing. Can we like maybe look at the implementation of GL buffer data? Can we just like kind of see what the fuck is complaining about here? All right, let's take a little peeksies. So data is, he's got some stuff in here. His length is 8, which feels very short. Very short. So we take in a GL buffer data, which has a pointer and a length. Oh, maybe this is the wrong one. Fuck. Yeah, we don't know which of these. Here we go. Length 10,000. This feels like the right one. This feels like the right one. So the target is this, the data is this, and the usage is this. Okay. But he's saying that the wrong buffer is bound. So I guess we kind of need to play this too. Which is not very clear at all. Okay. So can we look at maybe like what's in like this GL objects? We have a bunch of texture objects. That makes sense. Uniform locations. Oh, fuck. We're not freeing the uniform locations, which is probably bad. We do need to free those. We do need to free those if we're spawning this renderer over and over again. Fuck. Can we like, I think that if we just call delete buffer with our uniforms, I think it just happens to do the right thing, which is kind of cheating, but I'm going to abuse this for now. Because I think that the GL, we kind of like store all of these things in the same global array. So we're just gonna like delete buffer for all of these things. Just in case. I don't think this is the problem, but you know, it doesn't hurt. Doesn't hurt. Should be self dot, and then I guess we do like GUI.gl delete buffer self dot, find the colon, replace this. There we go. And this would be lock, I guess. And then we need to delete the program as well. Oh no, because GL delete buffer will call the wrong fucking free function. Oh, what a pain in my ass, man. Pain in my ass. Okay, instead, So we don't really handle like rapid construction and destruction of a renderer like this. It's just like not, we haven't like set up the APIs to do that. So let's kind of like try to store this thing long-lived, I guess. Heuristic renderer is a heuristic renderer, and then we will change this thing so that our heuristic renderer on init will not take in the closest this stuff. Right, so he's not going to do any, I guess he will like create his vertex buffer object and vertex array object, but not like do anything with them. And then we'll have like feed data. Can you quickly show how you set up the vertex attribute pointers? Sure, in a second. I just want to get this closest stop lookup. I just want to get this kind of starting to look right first, and then I will. So here, we're going to kind of do this stuff where we create our thing. And then here we're going to create the buffers, but we're not going to do anything with them. So these guys get kind of fed in like this. Then we do this stuff here. Yep. And then here, so we bind our vertex array object. We find our vertex buffer object. We feed this with the data we haven't passed in yet. So that goes down here. So I guess we have to create our vertex buffer first. Then we do all of this GL stuff. So we create our bind our vertex array, bind our vertex buffer, set the buffer data to match our thing. Our vertex attribute pointer is supposed to, this should be 8 probably, not 4. So this is the stride. Oh, stride should be 16 no matter what. Stride should be 16. 4 floats. So 16 stride for both of these. This is 8 offset, this is 0 offset. Now it's correct. Okay. I swear I would have got there without you telling me. I promise. But it's also good that you told me. So this gets down here to the feed function. Now we set like self num points here. Okay, and then here we set num points initially to 0. Okay. So now we can initialize this thing once on app init. So here we have like const heuristic renderer is a heuristic renderer, initialize with nothing. Here we set the heuristic renderer equals heuristic renderer. Does this thing fail now? Nothing in here is failable, so I guess we will not try to fail that. Then when we create this thing here, instead of creating a new one, we'll just feed it. So we'll say self heuristic renderer feed with this thing. And then this becomes self heuristic renderer bind. And then we render. All right. No, we can't panic here. Or we can't, you know what I mean. We can't throw. Throwing is the wrong word. We can't return an error. All right, let's try that. Let's see if this still complains at us. It might, but it might not. Who knows? Let's disable these debugger statements. Let's just see if he complains. I have my own abstraction layer, so I don't think about that trick because I tripped up too many times setting those attributes. Yeah, it is like not a nice API. Definitely not a nice API. Why is he like stuck? 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. Like, I don't really see why this should take any longer or less long now than it did before. Did I not build this in the right mode? I did. So what is it doing? That's a lot of Mississippi not to judge. Yeah, it feels like way too many Mississippis. I agree. But I don't really understand. It feels like the amount of time shouldn't have changed in that last iteration. That's why I'm confused. Oh, this okay. So we constructed the heuristic renderer. Enable transit and debug, and if we hit set path start, set path end, this is where we should start to see something. And still we just see this like one giant green dot in the bottom left. It's possible that that's more than one green dot. It's possible that like the spacing of the things that we're trying to draw are just like totally fucked up. So it'd be interesting to maybe. You only need render docs so you can actually view the buffers on the GPU. That does make sense. It does seem like we are doing something really fucking stupid in the way we debug. Let's at the very least. So we bind the vertex array. We set the view. Do we ever set the view state? We do. We set the lat center. We set the lawn center. I want to look at like what we are feeding this thing. So maybe here. We can do like GDB args this thing. Run. Fuck. Breakpoint here. No. Zig build. Release safe. And GDB args zig out in map output. Oh man, OpenGL stuff. I should just get better at debugging it. Because holy shit, this is taking way more time than I felt like it should have. This is like just eating like what we like an hour. We spent like an hour on this almost. Like holy shit, man, just get better. Like fucking stop sucking, you know? I may have seen a bug earlier, something like min distance instead of less than. Min dis greater than instead of less than. Okay, good info. I don't think that'll be it, but we can see. Enable transit, set path end. Okay, so info locals optimized out. Fuck my life. List. Can we look at like vertex buff? No symbol vertex buff. I'm going to lose my mind. I guess we go back to printf debugging. Printf. Because I can't compile in debug mode. It's just too slow with the transit stuff right now. So we'll just do it this way. Std log debug, and we will log vertex buff. Let's just see if it's like kind of reasonable. I guess fuck GDB. We're too good for that shit. And by too good, I mean too shit. I think we wanted to compile with LTO off as well because it's too slow. All right. The fact that we're getting one dot in the bottom left is also very funny. Okay, he's taking like forever to initialize, as he does because we suck ass. We set the path start, we set the path end. Okay, so the question is does this vertex buffer look sane? Who knows? Some of these numbers are really big and some of them are really small. Right, we're seeing alternating big numbers and small numbers. I guess it also depends on like the size of the map. That destroyed the bitrate. Oopsies. But is it one dot? I don't think so. Dun dun dun. Yeah, it does seem like very likely that it's many dots, huh? I guess we could try to zoom in and take a little peek skis. That would be an interesting piece of information. So like over here, do we ever see more than one? Oh! Okay. So these are a grid of points. Called it. Yeah, good eye, good eye, good eye. So then the question becomes, why are they in the corner like that? It must be that in our closest our closest way thing, probably the width and height are, these are probably like relative to some location that I got wrong. So it would be in this IDX to pause thing. So we just take the fucking position, we take the index, and we divide it by the width. So I don't think that the distance should matter here. No. I think this is right. If the closest distance is greater than the distance, then we reassign it. We're trying to get the smallest distance. Right? So this should be if dist is less than closest dist. Like, that's the same thing. I think. Right? We had it this way. But it doesn't really matter. Closest, and even then, we shouldn't, like, the points, the location of the points shouldn't matter. The closest, like, these X and Y positions are unrelated to the closest point thing. They should be. These should just be, you know, these things. What is in meter metadata? What is in this thing? Lat long to meters. He returns a meter metadata, which is just the width and the height of the new. Yeah, of the new thing. And their offsets. Oh, hold on. Divided by X samples in both lines. Should be Y samples. Possible. Let's see. In closest stop lookup. This is width height. These should both be X samples because the storage format is like, 0, 1, 2, 3, 4, 5, 6, 7, right? And so if your width here is 4, so your Y index is like 4 over 4 or 4 mod, like 3 mod 4 or 4 over 4. So that's correct. Let's look at this index to position again. So we say the width of the entire screen is like 100, for example. And so if we take our X position of 5 and we divide it by 100, that's wrong. We want it so that if 5, we're missing a crucial thing in here, which is the number of samples. We are missing a crucial piece in here, which is num samples. There we go. This makes way more sense. Num samples f is an f32 is equal to float from int of num samples, right? Because we want it to be that sample number 25 is the width of the thing, right? So that means that we need to say that this is the index over num samples f minus 1 times the length, right? We want it so that index 24 is the width. So if we have 25 elements, index 24 should be at width 25 if the width is also 25. So this should be minus 1. There we go. So X samples and Y samples. Fucking math, man. Gets you every time. It's a hard life out here. It's a hard fucking life. I am lost in the sauce. Yeah, I didn't explain this very well. I was trying to make it so that we have 1, 2, 3, 4, 5, like on this box, right? And I was trying to make it so that fifth sample is width of thing, which means that we need to know if we're like the fifth index in, we need like, you know, if this is for index 0, 1, 2, 3, we want like 3 over 4 times width is what we were trying to do. I just fucked that up like heavily. So let's try again. Enable, debug, start, and oh, that's so much better. Look at that. Look at that 6-sit grid. Okay, thank God. We got there. We got there, guys. It just took a fucking hour, but we got there. Okay. So now let's fucking fix that heuristic renderer. Let's go back to not fucking logging this shit. Let's go back to our fragment thing. Heuristic, what was it? Closest stop GLSL. This now we want to take our red and green values and stick them, or blue values, stick them back in here. We want the point size to not be like fucking massive. Point size, we want this back to be like 10. You know, sometimes you make stupid little mistakes and it ruins your fucking day, and that's okay. It's part of developing. I'm glad we finally got there. I would have lost my mind though if we spent much more time on it. All right. Start. End. Everything is just hard fucking cyan. Which means that means what? It is true that this is going to shoot us towards infinity, which is not what I want. We want, if things are close, to be 1.0. Oh no, yeah, this is right. So if the distance is really, really big, oh yeah, if the distance is really big, we get close to infinity. This is not what I wanted at all. I want just big, big, big go to 0. Yes. So that means, oh yeah, so 1 over big, big, big gets closer and closer to 0 as we get bigger and bigger. That makes sense. And dist 0 goes to 1. Okay, so this should be fine. Right, this is guaranteed to be between 0 and 1. I guess dist, if it's not, if this is possibly non-negative, if this is possibly negative, then this is a problem. But this should always be 0 to 1. Or sorry, it should be 0 to infinity, like, because length should be always positive. Okay, let's try, oh, this is 1.0 still. This should be 0. That could be affecting my understanding of the problem. Could be. Could be. All right. Let's give him another try. Give him another try. All right. Debug, start, end. Okay, everything's just raw blue. Okay, I'm more okay with that. So the question is why is this guy not close? It could just be that this needs to be like scaled up by some amount, right? If the length is always high, then this would be a problem. So we can maybe we'll take in a scaling factor here. What is it? Uniform float. Vertex closest stop. So we have uniform float dist scale. And then in our heuristic renderer, we will say that we have a dist scale uniform. Right? This gets saved here. Oops. go back. Where the fuck am I? I'm over here. And then we save dist scale here. And then when we render this thing, we'll pass in a dist scale. We'll say self inner dist scale set dist scale. And then just in appzig, we have to set a distance scale here. And we'll set it to like 1.0 initially. And we have to hook this up to a slider. We have to hook it up to a slider, which is fine. Heuristic renderer. So here we need to pass in dist scale, and then in native Glufwa, we are going to add some sort of like input float for distance scale, and then fucking distance scale, distance scale, distance scale. Like, distance scale like this, and then like distance scale like this, and then one more. There we go. I think that's it. So now we should be able to punch it. Fuck! It's because here we called it dist scale, not distant scale. Here, okay. Let's try again. We'll try again. Please, 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 please. I'm gonna lose my mind. All right. Now we wait like 10 seconds for the fucking app to initialize, which we will have to fix. But one day. One day at a time. Okay. So let's try setting a distance scale here. So we'll set start, end. And then let's see if we can set a scale that makes these not all blue. So we expect this is too small, I think. So we'll set like something like 0.001. What about like a big number? 50. Huh. It's kind of hard to know. How fucked up this is. So the length of the closest stop is, I mean, we can kind of assume that we're kind of like, what can we assume like is a good number here? We can assume that like close stops might be within like 50 meters or like 100 meters. So if we want 100 to be big number, so we want, this means that this is going to be like, we want to like divide by 100 to make it close to 1.0. So 0.01 I feel like makes sense, which means it's hard to know. Can we just put like the closest stop values directly in here? Like this. Like, let's just kind of like try to get a feel for like for this thing, and then I guess maybe we will multiply these. Oh, we didn't actually use the distance scale. That would do it, huh? Fuck. I swear I didn't see your message before I said that, but you won't believe me. I swear I came to that conclusion by myself, and maybe I saw it in my peripheral. Who knows? So the code for the randomly changed room balls you're using above your frame, completely unrelated to the actual map, or are they very close related? Completely unrelated. Completely unrelated. That's just there so that we keep zoomer attention. If we don't keep zoomer attention, how will we ever learn programming? All right. Start, end. Okay, now we multiply 0.01. Oh, there we go. There we go. So that feels kind of okay. That feels kind of okay. Okay. Sick. That's pretty sick. Okay, so we can see like this guy thinks he's pretty close. These guys think they're very far. That makes sense. This guy thinks he's kind of close. This guy thinks he's kind of close. So like, you know, maybe it's kind of working. Yeah, and if we change the scale, we can definitely see that like, you know, that's an approximation of the bus grid graph. A pretty shitty one. You know, but it's kind of doing something. It's kind of doing something. That's kind of nice. Okay, so now what I want to do is I want to change these to increase the grid res once for fun. Yeah, that's not a bad idea. It's not a bad idea. Well, I was gonna just go for like straight interpolation, but I am down to just fucking increase the fucking the size. I'm down. I'm down. Where is that? That's in closest stop lookup, and let's just kind of like, you know, maybe we'll go like 100 by 100. Wow, let's get fucking crazy out here. Let's get crazy. All right, I don't know how long if that's gonna like heavily increase the time to calculate here. That actually wasn't too bad. That wasn't too bad. Oh, I guess I don't know if we are calculating. We're not calculating until we run this, I guess. Oh, but even that was still not fine. So we said 0.005. 01, 02, 03, 04. Yeah, okay, so you can kind of see maybe 005. I don't know what I'm trying to do. It's kind of like hard to see anything of value, but it does feel like it's working. It does feel like it's working. Okay. So what I want to do next is I want to at least get to the point where we're drawing. I want to draw the whole heat map with interpolation now on the GPU. So I want to do like, basically I want to switch this from doing point rendering to like triangle strip, right? Which means that we're going to have to not render them in the order that they appear in the grid, but by like element index. So let's start by making EBO. Element buffer object, I should say. This gets stored here. Then when we kind of feed this thing, we're going to say that we have like I don't know, bind buffer, GL element buffer, array buffer. And we're going to have to like set this thing up where we set the data to elements. So it's like, what we say it was like 0. Hold on. It was, we want to do for 0 to closest stop look up Y samples. -1, I think. I guess we said that we were going X first, then Y. So for 0 to closest stop lookup dot X samples, we have an X value. We have a Y value. And we said that we wanted to iterate these things essentially like this. Right? So this is, I guess we're still iterating by Y first, then by X, but it's just for 0 to y, for 0 y to y plus 1. Here we go. This is it. So this will give us here, then here, and then after we iterate this row, it'll give us here, then here. Nice. We want to draw a full strip here. And I don't know if primitive restart index works for this. I hope it does. So we're going to want to, like, EBO data is going to be a... I'm just going to use an array list for now. Like a lazy piece of shit. So we go like this. We defer EBO data D in it. Okay. And then here we say EBO data dot append y2 times closest stop lookup dot storage dot len plus x. And we probably have to incast this. Okay. Then every row. So for every row, I guess we kind of want it to go this way, huh? We want to go iterate by y then x. Yeah. Then for every row, we say EBO data dot append stud math int max for a U32. And this should make it so that we kind of like interrupt strips. So we're gonna draw one strip across the top, then break, then a next strip, then break, then a next strip, then break. That's what I'm hoping to see here. And so kind of after all of this, we just have to bind the element buffer data. So this becomes element array buffer, and we do EBO data items pointer and EBO data items len. And the width, the number of things here is still 4. Don't I need to somewhere say that my things are unsigned ints? I guess that's here. I do GL draw elements, which I think means I need to GUI bind buffer GL element buffer array buffer self inner EBO. I'm not actually positive about that, but it feels kind of right. And then GL draw element says that I have like points. I'm drawing this many of them of this type. So this is this many unsigned ints starting at offset 0. And I hope to see basically no change in behavior. That's what we're hoping to see here. We're hoping to see all the lines, the things still drawn, and then we're hoping that we can change this to triangle strip and just see like a nice contiguous color change. That is what we are hoping to see. All right. Man, I'm disappointed a little bit with how long this OpenGL stuff took, but I should learn to get over it. I was hoping to get to like kind of the whole shebang today. So instead of what I wanted to see, I'm seeing like a fucking blue ass line at the bottom, which means that we really fucked something up. I want to look at this again. So here, it's almost like we're only ever drawing like the bottom of the buffer. So let me think about this again. So we're trying to draw elements on this EBO. So here we say, we generate our EBO data, we bind the EBO, we say, we want to draw this many things. And I'm going to start with, instead of trying to do this tricky shit, let's just try drawing everything now. Like draw them as individual point. Like start simple. Start simple. This is wrong. That's why I'm actually looking at this right now, and I see that the length thing here is fucking stupid. This should be the width. It should be like this. Programmer underestimates. Shocker. Yeah, that's a classic. I consistently say this should be easy, and then for some reason sometimes it's not easy. And for some reason sometimes it takes up to like 10 times as long as I said it would. And it's like, you know, when is it my fault? Immediately. It's immediately my fault, but I pretend it's not. All right. There we go. That's better. That is better. Okay, so now if we change this to triangle strip, I kind of expect that it will just do the right thing. Let's just see what happens if we do triangle strip. That's why I have poker planning in the context of agile shitty ass development. Well, I mean, I think that the poker planning doesn't even really help. I think that like the problem just keeps like because I am informed very well about how fast I think I can do something, and I guess really wrong, right? And if like everybody is informed about how well they do something and they all guess they're all equally optimistic, then like it doesn't help. Okay, so this triangle strip did not do what I wanted, surprisingly. What is this white dot here? What is that? I don't know. Yeah, I don't really understand why drawing a triangle strip here changes behavior in the slightest, to be honest. Let's try drawing a line strip. I'm curious about drawing a line strip here. That white dot will be there forever, I'm calling it. It does seem like the type of thing that I'll just ignore, huh? I am really into ignoring problems. The only good scrum involves rugby. Nice. Rugby tackle, hell yeah. All right. Okay, so the line strip is kind of indicating that I didn't do this the way I wanted, which would explain why there's no triangles, right? We should be seeing zigzags, and instead we're just seeing like horizontal fucking lines. So, this would do it, because y to y plus 1 only gives me one y value. I want y to y plus 2. All right. This is the one, guys. This is the one. We're going to see a very pretty graph. Not graph. Overlay. This is the one. No, because we're still in line mode. It's not the one. It's not the one. And I never said it would be. All right. So here we're hoping to see basically a zigzag pattern like this. When we go into transit mode, path plan on, try to pen something. That looks right. Down, up, down, up, down, up, down, up, down, up. Yeah, that feels right to me. It's not in the order I thought it would be, but it's maybe okay. So let's turn back on triangle strip here and see what it looks like. We'll see. And we're hoping to see some smooth lines that kind of, or smooth like heat map that trends towards the bus stops. That's what we're hoping for. We can cross our fingers. Please, sir, please. I just want it to work. All right. Moment of truth, baby. Moment of truth. Wait. It's pretty fucking hard to tell, to be honest. There's something that looks surprisingly wrong here. It would be interesting to maybe look at, let's reduce the alpha. I don't know what I'm looking at, but it looks nice. Yeah, it does kind of look pretty, huh? let's kind of reduce alpha and see if that helps us at all. Fragment, closest stop. So if we just change this alpha down to like 0.1, that's probably reasonable. I guess we could just draw it underneath as well. But whatever. I guess, I wonder if it's faster to set up the GUI callback with alpha as a uniform, or if it's faster to recompile and relaunch until I get the right alpha value. Because both seem slow as shit. 0.1 is not high enough alpha, I don't think, but we can just try to look anyways. Yeah, it's really hard to see. So let's kind of go 0.5. We should have started 0.5. Add a side mission to find the white dot. Add a side mission to save frame to ping. Use wallpaper. Yeah, that would be kind of fun. There are some things in like, there is something fun about like the types of mistakes and the types of like things you end up accidentally seeing when you're working with this type of visualization is kind of fun. There's something about it. All right, there we go. That's like visible. So we want to go back to step amount. No, distance scale. So it definitely does not really. Does it feel like these things are kind of like tracking the bus routes in any way, shape, or form? Not really, huh? This part kind of feels like it. But like, what the fuck is going on here? This stuff over here feels like it's kind of working. I don't really understand this like red line here. I guess, are we bilinearly interpolating correctly? It's possible that we are not interpolating in a way that makes sense. It's possible. It's possible. We should also like, because like what I would hope to see, like this line looks like kind of weirdly rotated from the, like I would expect it to kind of like track this way. I wonder if like the vectors we're storing are in the wrong direction in some way, shape, or form. So here we're saying the closest vec is the stop pause subtracted from the sample pause. Stop pause subtracted from the sample pause. Let's think about that. So wait, so this is, this is other subtracted from us. So the other, so this is pointing towards the bus stop. This is pointing towards the bus stop, which I think makes sense. So these feel like they're working. I mean, we could also try like just like really like cranking up the sample size or the like the sampling rate and see kind of how that affects us. Right? It could be that this concept of just linearly interpolating between the vectors is not reasonable. Mr. DLL is asking me to try nearest instead of interpolating. That doesn't seem crazy. Does not seem crazy. Although, no, I don't think that really, like, I don't know what I would expect to see from there, to be honest. Okay, so this is taking a long ass time. Oh, fuck. So if I increase this too much, it like sucks at, how do I say this? It like, I think that if we don't respond closely enough, quickly enough in like a render loop, open the GLFW window like crashes. I think I saw like a Wayland Sentinel timeout thing that's kind of fucking annoying, but I don't really know how to disable. I haven't really looked into it, so maybe it's easy and I should just do it. Okay. 0.01. Just to see what you get. If it's still messed up, then it would confuse me, but it may be a misunderstanding. I see. So you're kind of saying that like with nearest, you should see. I'm just trying to imagine like what I expect to see with nearest. I kind of expect to see like. Okay, can we just go back to points? Like, let's just go back to points. And double check that that looks okay. Let's kind of see like what kind of fucking scale are we looking at? Vertical looks like right, and there's like a 45-degree rotation if you stare it down. Yeah, it does feel like there's some sort of weird 45-degree rotation happening. I agree with that. Which I guess could have to do with like how OpenGL is deciding to interpolate. It's possible. Possible. Debug path planning, transit integration, start. Okay, so we should see like our sample size is like approximately every 2 blocks. Approximately. And like if I do 0.001, 05. 0.005, I feel like I feel like if I zoom out to this level, it does look like these things are like following bus routes. I guess the triangle interpolation might be fucking with us in some way. Right? I kind of want like quad interpolation. I don't really know how that plays into this. The 45 degrees thing, it actually could. I'll bet you that's fucking related. I'll bet you that's related. So, I bet you if we were to draw the triangle strip and lines, I bet you we would see that the places of like weird hotspots are on the diagonals. I bet you if we do this, we are going to see something kind of interesting. I bet we will see something interesting. Because I just kind of assumed that the fragment shader would do what I want it to do, but I don't think it does. Can you do like fragment shader quad interpolation? Like, is that something that you can do? End. Boom, boom, end. So here we have distance scale 0.01. So maybe those lines aren't. I don't know, man. It's not like I expected. It's not like I expected. And then, like, why the fuck is anything in this region red at all? Oh, I see what's happening. I think I see what's happening. Okay. So hold on. Let's try to screenshot this in some way that makes sense. So I think there's some fucked up shit. Maybe this just doesn't work the way I thought. This might just be a flawed concept. Might just be a flawed concept. Okay. I thought that I fucking put it on my clipboard, but I guess I didn't. That's okay. I didn't want it on my clipboard anyways. So I think that what's happening is I'm just a fucking idiot, and like here, the closest bus stop is here, and here, the closest bus stop is here. And so we have an orange line down the middle because fucking averaging these two vectors goes to zero. Goes to zero. Right? So I actually kind of want like different behavior if they're pointed towards each other or away from each other, right? I only want this to happen in the scenario, like on this scenario. So you almost want like, you have like its position as well. You have its position as well. So you can do. That's what I had in mind when I was thinking about nearest. Ah, I see. I see. So what does this tell us? What does this tell us? You want like. Can't you go out on the left of the screen and come in from the right? Just kidding. Oh, fuck. I was trying to understand, like, what the fuck are you talking about initially? But I was like, oh, you got me, you got me. Which I wonder if this explains these orange lines in some way where, like, you know, it's kind of like something like this. I don't really know. I'm just kind of like guessing that there's like some sort of like diagonal shit caused by 90-degree angles. That a dot of the two vectors, isn't it, goes to zero when opposite. So I think that with the way that this is laid out right now, these two things are completely indistinguishable from each other, right? This and this is the same vectors. Like when you take like the origin of the vectors and you move them on top of each other, these are the same. And so we need to know something. I don't really know how to like. There's some obvious way to tell this. Like it's so. It feels apparent to me. I just can't figure out what it is. I guess you have to use the like origins of these points in some way. Right? Like you have 2 points. And you subtract like if this vector and this vector line up. And this vector and this vector line up. There's something about that I'm just not seeing right now. And then also I don't know if whatever solution we come up with is going to be easily implementable on the GPU. I guess we just need to make sure that like we interpolate the right values. Fuck. I should have seen this coming. But that's fine. That's fine. Okay. You know what? I am going to think about it overnight because we're past 4 o'clock right now. We did something today. We visualized a thing. And the thing that we visualized, it turns out, is not something valuable in any way, shape, or form. But maybe it's a step on the right way. I don't know. I'll have to think about it. So, thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to around 4 o'clock Pacific time. The YouTube gets VODs from 2 o'clock to 4 o'clock. And, you know, we get some Twitch only and Patreon, Twitch/Patreon stuff going from 12:30 to 2. If you're new here, there's a YouTube link in the Twitch description. Where we have all of our stuff organized in playlists. So right now we're working on this like Google Maps replacement, but there's other stuff in here. We want to go check it out. QR code decoder was kind of fun. Zero implementation was kind of fun. Video editor was fun. Neural network was fun. Operating system was fun. So if you want to check those out, they're there. There's a GitHub link. Apparently GitHub is down, so we can't show that right now. But there is a GitHub link where the code for this will eventually show up. This code will not show up there because it's broken, so I'm not going to fucking merge it. But maybe something that resembles this when we get closer to a real answer in the future. What else? Discord link in the Twitch description as well if you want to chat about shit offline or get like announcements about when stuff goes up. Otherwise, I think that's all we have to plug. Like, subscribe, Twitch Prime, YouTube. Goodbye. Twitch, let's find someone's parade.